Okay, there's a few new topics. I understand a lot of people haven't seen derivatives before or vectors. So this was a good homework problem. I know you freak out that I assign these things, but that's kind of why I assign them, is so that you can learn how to use them, because we're going to need them later. Okay, so we've got a vector. It's a function of time, so I'm going to go ahead and write, explicitly that it's a function of time, and it's given by 9.60 times time in the I hat direction, plus 8.65 units in the j hat direction, and then minus 1.00 times t squared in the k hat direction. So this is the x component, the y component, and the z component of this position. So these are all coordinates, basically. And this is in units of meters. Okay, and it is asking, what is the particle's velocity? Well, the velocity, we'll just blindly do this. It's going to be the derivative with respect to time of the position. So remember, in the 1D case, if this was x, or sorry, if this was time and this was x, and we had something going like this, so the position along the x-axis, the particle's moving, the slope of this curve describes the velocity, the instantaneous velocity, and the slope is given by this derivative. So it's the same thing in the 3D case with vectors. The velocity as a function of time is given by the derivative with respect to time. And realize you haven't seen this, the back of your book, the appendices, show how to take the derivative. So what I'm going to do is take the derivative of each component separately. So I'm going to take the derivative with respect to time of 9.60 times t, and that's all going to be in the I hat direction. And then I'm also going to take a derivative with respect to time of the y hat direction, 8.65 j hat direction, and then I'm going to add a negative number, take the derivative of negative 1.00 t squared in the k hat direction. Okay, now look up in the back of your book. If you take the derivative with respect to time of the variable, you imagine this is t to the 1. And when you take a derivative, you knock down, you take this exponent down in front and multiply it, all this stuff out here, and then you subtract 1 from the exponent. So this is going to be 1 times 9.6 to the t, and then I got 1 minus 1, I'm going to subtract 1, this is 0. And so any number to the 0 is 1. So I've basically got 9.6 left. Okay, if I take the derivative of a constant, so 8.65, so this would be the y component with respect to time. Well, it's constant, so the slope is 0. And sure enough, if I take the derivative of a constant, it's 0. It's not changing. So plus 0 j hat. And then I use my same kind of algorithm here to take the derivative of this. So now I've got first a negative 1.0, then I've got times the exponent 2, and I've got t 2 minus 1 k hat direction. And so this is equal to 9.60, and that's it, I hat. And I've got 0 j hat, and then I've got minus 2.00 single power of t, that's in the k hat direction. Okay, so that's my velocity. There it is. Okay, we do the same thing with acceleration. Acceleration is the rate of change of velocity. Okay? It's the rate of change of velocity. So we take the derivative with respect to time of the velocity now that we just found. by the way, by doing this, you're going to be taking the second derivative with respect to time of the position vector. See, you've never seen this stuff before, and now you're really moving. You're taking second derivatives already. Okay, so take the derivative with respect to time of this. We'll do the same thing. d dt of 9.60 in the i-hat direction. I'll take the minus sign out front here now. Minus derivative with respect to time of 2.00 times time, and that's in the k-hat direction. Well, 9.6 is always 9.6. It's not changing, so that's a constant again, and the slope of that is 0. So the rate of change of a constant is 0. That's 0. So that's easy. This one I'm going to knock down a 1, and then I'm going to have t to the 1 minus 1, which is t to the 0, which is just 1. So here I'm going to get minus 2.00 k hat. And there you go. Circle your answers. You might want to write them out again just so we know what you're talking about. V of t is equal to 9.60 I hat minus 2.00 times time k hat. And then a is a function of time is equal to negative 2.00 k hat. Circle your answer. Okay.